Number 9 on topic 1 is negative 1/3, and that's the complex fractions, which a lot of you just despise complex fractions. And really all a complex fraction is a fraction, a big old fraction with some fractions inside of it. And that's why we call it complex. And our goal is to get rid of this denominator, but maintaining the fraction without changing it. So we use what we call the LCD method. Now, this doesn't have a denominator, so, I mean, it does. It's a 1. We're going to put a 1 there as a place setter. And the same thing with the 6. And then we're going to look at each denominator, x, the 1. I could put a 1 here if you like. And a 1 here if you like. We're going to look at the x, the 1, and the x, and determine the least common denominator, which is x. I'm going to multiply each term, 1, 2, 3, 4, all 4 terms by x. Some of you like to do x over 1. That's cool with me. So I did that to illustrate it there. Now in the next step, the fractions have to be gone. Because this LCD method, and we're using the LCD method here, eliminates denominators. We want those denominators to go away because we're trying to chip away at this and simplify it. So now the x is simplified to 1, and I'm left just with a lonely old 4 there. Bring down the negative. The 2 and the x can't do anything. You get 2x. Nothing here. You have 6x. Bring them the negative. Here the x is simplified to 1. You have the 12. You see how it's no longer complex? Now this is just a simple rational expression, a fraction, that maybe requires factoring. If there is any factoring that would lead to simplification, we do that. And you can see here that when I factor out a 2 using greatest common factor, I'm left with 2 minus x. And then a denominator using greatest common factor, when I factor out a 6, I'm left with x minus 2. Now some simplification can go on here. The 2 goes into the 6 one time. But more importantly, these two things here, since they're complete opposite signs, there's that negative 1 again. Negative 1 on top, 1 on the bottom. And this becomes a 1, and this becomes a 3. So I'm left with 1 times negative 1 in the numerator, 3 times 1 in the denominator, and that's how I get to the 1/3. And it's really interesting because as a part 1, if you would have plugged in any number, except 0 of course, because that would cause division by 0, in the original complex fraction, it would have given you your negative 1/3. So mock substitution here as a part 1 is awesome, and mock substitution to check as a part 2 is awesome as well. Still on topic 1, number 10, I chose this complex fraction because it was a little bit different. The simplified version of this was negative y. So if we look at this complex fraction over here, this is a little different because you have some binomial denominators. I'm going to say my last name. Denominators. So I wanted to show you one of those because that's actually a common question. Once again, we want to use the LCD method. And the LCD method says we're going to multiply each numerator by the least common denominator of all the terms. And we have 1, 2, 3 terms here. So I'm just going to put this over 1. And the least common denominator is going to be x minus y. So we're going to multiply this by x minus y over 1, this by x minus y over 1, and this by x minus y over 1. And you might want to put parentheses around these binomials, which I did here. And this is where the multiplication is going on. Now in my next step, the fractions should be gone. If they're not, you did something wrong. That's what the LCD method does. It eliminates those denominators. Nothing can be eliminated here, so I just wrote out the x minus y. Bring down the subtraction sign. And these binomials simplify to 1, bring down the x. In the bottom here, this simplifies to 1. Now I have x minus y minus x, which when I simplify that further, the x's cancel to 0, and I'm left with negative y over 1, or just negative y. Once again, as a part 1, this could have been done with mock substitution. As a part 2, it could have been checked with mock substitution.